We are happy that we have applied for Texas Instruments contest. We, the students of SNS College of Technology, along with our mentors, support. Our project is based on the implementation in the automobile that ensures safety with the green electricity implementation. The automobile's invention has been increased with the help of electronics and communication in the day-to-day life. The inventions altogether made a vast variety of vehicles that comes into the trend in the day-to-day life. For examples, you can see the autonomous cars that has been let out by the Google that had a test drive too. But the tests are also increasing. Here is a project to serve some of the effects. So this shows our project which explains. Here our mate is on this role to explain the real-time implementation by interfacing hardware and software. Here the MATLAB and the software kit forms our entire project. This is the RFID module which reads the RFID card. A relay is implemented to show the signal of its output. A ignition motor to indicate whether the ID is matched or not. Peltier tile to provide thermoelectric effect that provides battery backup. Digital fuel sensor that is used to measure the level of fuel in the fuel tank. The relay circuit is made for the light as well as the gas sensor to show its signal output. This LCD display forms one part which displays the temperature, the Peltier's ADC value, and the number of kilometers that can be traveled by the digital fuel sensor's measurement. This forms a gas sensor that is driven by using IC. This forms the temperature sensor TMP100 of Texas Instruments. This is the Hall effect sensor DRV5053 of Texas. This forms a dark sensor made from NE555 IC. This is the second setup of our project that displays the air pressure's output, gas sensors as well as dark sensor. This forms our entire kit. So the sensor applications and its process is as shown in this kit implementation. So this forms a first part with the LCD display of temperature, Peltier and the kilometer that can be traveled with the available fuel. The microcontroller drives the entire setup which is MSP430 of Texas Instrument. This is the temperature sensor that measures the temperature inside the automobile, and now it is indicated that the temperature is 32 degrees centigrade. The next is the Peltier tile which provides the thermoelectric effect with the hot and cold junction. So by holding the heat of our body, the temperature variation is shown and that is displayed as an ADC value in the LCD. This is used as a support for the battery backup. The ADC value varies depending upon the hot and the cold junction that forms the thermoelectric effect basic concept. The next comes the digital fuel sensor's indication. So based upon the distance measurement and the ultrasonic sensor senses the level of fuel inside the fuel tank. With the mileage level of our particular automobile, the kilometer that could be traveled with the available IC can be measured and that is displayed here over the LCD display. So this forms the entire part of the first module of our hardware kit. The next part comes the second LCD module that displays the RPM value, the gas sensor's indication and the light sensor's indication. So this is a gas sensor that is made to detect the carbon monoxide gas that comes out of the air conditioner in such cases. The IC is the comparator LM358 of Texas. This is a gas emulsifying liquid. When the gas from this liquid is exposed, the gas sensor senses the fuel smell, and once the gas is sensed, the display is shown. So initially the gas sense will be off. And once when the gas is let out, the gas sensor senses the gas, and that is displayed on the LCD. The relay circuit is just shown to indicate with an LED that it works. So motor is connected. Once when the gas is detected, the windows of our car or automobile is made to move down. So the gas inside is let out by saving us from the toxic gases. The next comes the Hall effect sensor, which is the RE5053 of Texas Instrument. The magnetizing concept is used here, where the magnet is placed in the rim of the tires so that when the air pressure is reduced, the magnet comes in contact with the sensor and thus the RPM level is indicated. With this RPM level, the pressure reduced can be detected and thus it is displayed in the LCD. Both the south poles and north poles has been detected. Next comes the dark sensor setup. The dark sensor made of Ne555, that is Texas IC, detects the darkness. The LDR senses the darkness outside and indicates that it's dark. A relay is made to switch on sensing this darkness. The RFID card is used to read, and when the ID is not matched, our user is not able to start or ignite his card. So we go for a MATLAB software where we initially save the database of our user by the enroll program as shown. Once the enroll program is shown, the data is fetched in. Now the user takes his real-time image by sitting on his driver's seat. This image then is checked for a database inside the server. The matching of the image is sensed, and once the image gets matched, the process goes on. Now the image is correlated and its output is checked for correctness. When the output is matched, our driver is able to drive his car. So you are on your seat belts to drive your car safely and securely. We thank Texas Instruments for giving this wonderful opportunity to express our views.